Now I'd like to welcome Mark Ransley. Mark is coming at my request to speak with us about an exciting European Commission funded project. And Mark, would you please introduce yourself and in the next 15 minutes go through some great material that you've provided for this. Tell me when you're ready and I'll advance the slides.
Excellent. Can everybody hear me?
Perfect.
Brilliant. Okay, well, thanks very much for having me for this. I'm keen to tell you all about this project, which we just concluded last week, the WEKIT project, which has been ongoing for 3 years now through this consortium of partners across the EU. It was awarded a €3 million Horizons 2020 grant, and you can see with this many partners, that's still not a great deal, but hopefully you'll be impressed by what we've done with it. The proposal was initially ranked #1 out of over 170 proposals in that call for funding. So you will now see the results of this. So these are the overall project objectives here, to essentially build a augmented reality headset or HoloLens based industrial training platform where experts would be able to go around their environment and record their workflow, their sequence of things that they're doing in a particular task, where then trainees would be able to put on the same wearables and view back the expert's experience and use that in an ordered, structured way to be able to learn a new skill more rapidly than before. So could we have the next slide, please?
Yeah, Mark, may I ask you to introduce yourself a little bit more, give us a little more context for who you are and how you came to be with us today?
Certainly. So I'm a researcher at Ravensbourne University, London, which is a specialised media university. It was just awarded its university status last year, so it's a very fresh and new and exciting place to be. And I work in the Learning Technology Research Centre there, where we investigate the applications of all sorts of new media and technologies to be able to enhance people's learning process. Is that enough?
Thank you. And you have these work packages. Can you tell us what work package you were involved with? Were you involved in all of them, or what was your role within the context of the project?
So I was mostly working on work package 4 and 5 and 3, and also in work package 6 as I was helping to conduct the industrial trials where we were testing out the platform with about 400 volunteers across the domains of aerospace, space itself in an astronaut training facility, and also across the medical sector. And I'll tell you more about the industrial trials in a bit. So as you can see, the project was divided up into a bunch of different work packages. There was an awful lot of crossover between them, but I thought you might find that interesting just to see how people go about putting together a platform like we have. So if we can go to the next one, I'll go through them one by one. Initially, the idea was to create a learning methodology to be able to do this with. So, how is this actually going to work? What things are people going to be able to see and do and interact with in order to be able to transfer knowledge using augmented reality? And so we developed what we believe to be the first pedagogical framework for augmented reality combined with wearable technology. And if we can go to the next slide, I'll give you some examples of this. So here's one of the concepts that we came up with for it, a directed focus, where an expert can place a marker somewhere in the environment around them, and then to the trainee, the headset will direct their attention to the place where it ought to be. Could we go to the next slide, please? Here's another one. This is Annotations, where the expert could pull up a task station or an element within an existing task station, and they would then be able to place photos or videos or 3D models or just plain text or audio recordings, a whole bunch of different things in order to show the trainee what is going on here. And could we go to the next one, please? So this one is Ghost Track, where we can use the HoloLens's pose estimation system and hand tracking in order to let the trainee step back and view exactly what the expert was doing at that point in time, at that point during the task, you could say, through this kind of ghost model. This was an earlier prototype. It did start to look a bit more human towards the end. So could we have the next one as well now? So this is going on to work package 2, integration. There were supposed to be some graphics on there, Christine. I don't know where they've gone. On the left-hand side, there were some extra panels.
Yes. Because they're a build.
Aha. Okay then. So here we go. This is work package 2, which was effectively devising the architecture of the system, the platform, how these different concepts that we want to integrate can all work together. And one of the things that came out of this was actually a new IEEE standard called ARLEM, which I believe Christine has been involved in as well. Is that right?
That's right.
Mm-hmm. So that's been going through a number of drafts at the moment, an awful lot if I recall, but I think it's been accepted now. I've not really been that involved in the IEEE standard for the project, but I still think it's quite a cool thing that's happened. But this gives you an idea of the way that these different elements can be conceived of in a kind of object-oriented way. Yeah, the way that we kind of divided up all the possible things that could happen within this platform. So that was the integration part. Could we have the next slide, please? And then work package 3 was the experience capture. So this was building the software itself where the expert would be able to wander around and perform their task, and the platform and software would be able to capture everything that they're seeing and doing, and additionally capture their biometrics at that point through a wearable harness that we built. So things such as their heart rate and their galvanic skin response and temperature levels. And I'll tell you more about that now. If we could go to the next slide, please. So for this component of the project, we selected a bunch of different biosensors, effectively just all the ones that were available that would work within a workplace, so not within lab conditions, but while somebody's actually on the move doing things. And that was one of the biggest challenges for my part of the work, actually, to be able to get these things to work in those kind of conditions. So we selected sensors and made a custom PCB, and then in the bottom right you can see all the electronics laid out. And if we go on to the next slide, you can see all of the electronics now integrated into a harness which is worn alongside the HoloLens, and all of the data from all of these things is being sent over to our a central computer elsewhere, which is then providing this stuff to a cloud platform, so that all of the recordings from experts, but also recordings of the participants can be saved for future reference. So that's a whole other work package later on the cloud platform. And here's a diagram demonstrating how the experience capturing API can work, where effectively somebody can wander around and sort of introduce task stations that are stored within a file. They can add all the different annotations, information coming from the biosensors and the HoloLens's own sensors, and then they can also integrate this with the central data hub as well, going to the cloud. Next slide, please. And this one is work package 4, which is another one I worked quite heavily on, which is the playback in the HoloLens. So the recorder and the player wound up being ultimately integrated into a single piece of software, WEKIT.1, but the two different strands of it, the recorder and the player, were kind of developed separately to begin with, or at least within two separate work packages. So we used a printed target to initialize the system in all cases, but you'd only need to do that once at the start of each instance of the recorder or player, and every time it was in a new environment. And then on the right we see an example of the user interface for this. There are actually two variants on the user interface developed in parallel. There was a kind of list-oriented one, and then there's also this card-oriented user interface, which you can see here. Could we go to the next slide, please? This section is talking about how we worked with the biosensors and the HoloLens, and what kind of analytical architecture we had for these sensors. So the harness, which you saw a few slides back, that's in the bottom right of this schematic. That and the HoloLens both feed their data wirelessly to an MQTT broker. That's effectively, if anybody's not familiar with MQTT, it's a server that just receives messages organized into different topics containing payloads with the, say, the variable of each sensor. And it's just running continuously, listening for messages from different things on the network. And then on that same computer, we have a bunch of real-time analysis daemons. So these were little Python scripts that can read data from the MQTT broker. They can then process it in order to extract higher order data. For instance, the pulse sensor is effectively just sending a reading of how much blood is in the tissue at that point in time. And then it would have to be buffered and processed in order to get the heart rate in BPM. So there's an example of the processing of the biosensor data, which can be fed back to the MQTT broker with these new higher order variables, which can then be visualized on the HoloLens, and the whole thing can then be backed up in the cloud. So could we have the next slide, please? Thanks. And this is an example of that entire schematic being put to use, where you can see in the HoloLens user interface, they're getting a visualization of their own kind of bodily condition, with the different variables being sensed by the harness. And if you look on the bottom right here, we see an example of that being put to use within a training environment, where somebody would be able to program the system to say, abort the task when somebody's pulse rate is getting too high, or it's getting too cold for them to be safe. Things like that, because you'll see in the industrial trials we have been preparing to do this in some pretty hostile environments. So could we have the next slide, please? Okay, this is WP5, where we were looking at how to integrate all of this into these industrial environments, how to make them suitable for the 3 use cases that we'd picked out, which were aerospace, space exploration, and medicine. So this was a participatory design workshop where we took all the different sensors, including the HoloLens, and we took experts from each of these 3 industrial use cases, and we got them to discuss for the day all the different considerations that would have to be put in place for this to work in their environment. And so they were placing sensors around the body, saying where they may work or where they may be problematic for this particular case. And this is how we devised the kind of layout for this harness that we wound up using. Could we have the next slide, please? So here are the wearables. Well, at least this was the first 2 generations of wearables. So we pursued these 2 in parallel. To the top one would account for some of the warmer places, such as at the astronaut training facility. It's got very, very hot inside their hangar where they simulate the Mars terrain. And so we needed something fairly cool. And then the one below that, it's a lot warmer, and so that would have been useful for the aircraft refurbishment task, which was actually located in Tromsø in the Arctic Circle, where when they opened the hangar doors, it got extremely cold. So these were 2 of the wearables that had, you can see things like pockets on the back to store the electronics, the central processor and the battery, and there were channels running along the material to take the sensors to their desired location. However, we did find that we took these to trial because we ran the trials in 2 phases, and we did find that these were not really suitable because it was very difficult to get a good fit with the participants with a range of different body sizes. So what we wound up doing eventually, could we go to the next slide, please, is throwing all of that out and going with this harness type design, which you saw way back, where it was much more adjustable and reconfigurable for each person. It was also an awful lot easier to make copies of it and to transport them around. And we found that this worked successfully in all the trials. So I have some pointers for anybody considering building industrial wearables. some design guidelines and things that we wish we'd known at the beginning, and we've learnt through doing this. Could we have the next slide, please? So now I'm going to talk a little bit about WP6, which was running the trials themselves. So we took the HoloLens and the harness and the network architecture. We took all of this out to these 3 locations, one at Lufttransport in Tromsø, where they maintain the air ambulance aircraft for the Arctic Circle, and the next one was at EBIT, which is an ultrasound scanning facility in Genoa, and the third one was at Altec, which is a space training center in Turin. So we went to all of these 3 things and showed the trial operators how to work with all of the equipment. We found experts that were willing to record their workflow during different tasks, and they also helped us find a lot of different volunteers in order to see whether the technology was effective as a training tool. And as I said earlier, we did it in 2 phases. One was about halfway through the project, just with what we had at that time, just to get some feedback. And then the second trials were quite near the end of the project, by which point the technology was working really well. So could we have the next slide, please? When participants finished the trials, undertaking a task using the experts' recorded experience, after that they were asked to fill in a survey or a set of surveys which covered things like their personal demographics, and then just how they found the experience overall, especially working with augmented reality. We had to devise a few new metrics in order to really assess some of this stuff, which you see with Tamara and Spine. And then we also gave them a knowledge assessment questionnaire just to see how effectively they'd retained the things that they'd been taught throughout that experience. And across all of these, we found the results to be pretty impressive. The participants generally really enjoyed working with the HoloLens and the harness. They found the UI to be quite pleasing to work with. The training examples worked well. We also had a control arm for each of these where they were just given written instructions to compare with, and we did find that they preferred using the HoloLens, not surprisingly, but also that there was an improvement in their knowledge absorption in the process. So could we have the next slide, please? And so here we are concluding that the WEKIT project is now finished, and we did manage to conceptualize, fabricate and test augmented reality and wearable technology training platform, and I should say model instead of mode, but a learning model to work with these things. We provided experts with a tool where they can elegantly capture what they're doing, and we found that they had everything that they needed really in order to explain what they're working with. Trainees were then able to learn from that through playing it back. And that, yes, participants were pleased with the platform, and that we've recorded what I believe to be a pretty valuable set of data where throughout the participants taking part in the trials, we recorded all of their biometrics, and now we're trying to cross-reference that, look for correlations in their learning outcomes, or even their perceptions of the technology, and see if there's any predictors. And there might be some that are not too obvious that are achieved with sensor fusion. And I believe that if we do this, then we may, in the future, be able to monitor people's biosignals live and then perform live real-time analysis, quite deep analysis on it, and then provide them with customized feedback. And then that may actually be able to help them to learn faster as they're doing this. And so I think that's all I have to say. Thank you very much.
Fantastic. Thank you very, very much. And that was right to the point, Mark. Perfect. Are there people who have some questions? We like to give you the opportunity to talk to Mark, but also, Mark, do you mind if I provide your contact information in the minutes of this meeting so that if people want to follow up with you directly, that can happen?
That's absolutely fine, yes. And I'd also recommend people visit wekit.eu, where we have the reports for all of these work packages, the final deliverables with all of the results in a lot more detail than I can do in a 15-minute talk.
Yes, perfect. Thank you. Any questions?
Yeah, so this is Brian from Boeing, and I actually have a mentee who is working on a master's thesis, I believe, and she's interested in using biometric feedback with some of the work stuff. So it might be good to get you guys connected and see, for you guys, we might be able to get some data out of the factory, some more data for the testing, and for her, it might make some pretty good data for her thesis that she's working on. Also, it's kind of, is there an opportunity, it occurred to me that as people are using the device, if there was some way to, you're noticing these biometric things going up and down, and there's an optimal level of stress. Below that, we're not engaged. Above that, cortisol takes over, and we start having muddled thinking and stuff like that. So I'm wondering if you guys have looked into offering, hey, we're noticing that you seem to be stressed. Take a break, 5 minutes, do some deep breathing, some stuff to help people to mitigate that. And then also, if you could separate out, what is the stress source? Is it the environment that you're in? Is it the device? If it's the device, well, here's some instructions for how to adjust it so that maybe it's a little more comfortable. I don't know, I'm just kind of thinking out loud, but it seems like there's a ton of opportunity there to not only find out more about how the user is interacting with the device and if they're enjoying it or not, how effective it is, but also ways to mitigate some of that on the fly, and then see if that indeed is effective as well through that feedback loop.
Absolutely, that's the holy grail right there, which I touched upon just in the final slide there, right at the bottom. But it's it's a vast thing to go after. It's got a lot of problems that people they're open research problems. Yeah, people don't have definitive answers to these things. There's an explosion of hardware available at the moment for wearable sensors of various sorts, but the analytical side of it hasn't delivered anything really profound yet. But I'm certain that it will, and it's a shame that we weren't able to do that within the project. But we had to gather a really big data set initially in order to to make the analysis worthwhile. And now we finally have that, but it did come in quite late as the trials concluded pretty close to the end of the project.
Well, kudos for embarking on this. I mean, that's very impressive. This is really difficult. There's a lot of moving parts, and you guys did a great job of kind of pulling it together and taking a really good cut at it. So I really appreciate your work.
Well, thanks very much. I mean, as I said earlier on in the WP3 slide, that a lot of the work from me was being able to make these sensors work under the conditions that they were, because there's a lot of promising research out there on links between different kind of physiological signals and affective states and learning rates and these kinds of things, but it's normally done under pretty well-controlled lab conditions. And having them in scenarios where people are moving around a lot and using their hands a lot, it took an awful lot of hardware and software work in order to get good data from all of the sensors. Because we found that even very high-end sensors, such as the Empatica E4, which retails for about £1,500, even that was really subject to motion artifacts in the pulse sensing data. And so yes, it's something I didn't touch on too much here because I wanted to talk to you guys more about the augmented reality side of it. But yeah, it was a big part of the work for me.
And if you would make available, you said you had a tip sheet for things that you learned. I'm really thankful for any of that you'd care to share. I think this is a really a great area, and you guys are hitting a greenfield space.
Thanks, Brian. Thanks. We're gonna. Any other questions? Looks like Richard. Are you okay? Oh, he muted himself. Okay, I thought Richard was gonna.
Where did we say we could find the result of research?
Okay, so on the WEKIT.eu, WEKIT.eu website, you can. One of the pop-down menus is public research results, or if you're really up to speed, you could go to the email that I sent out earlier this afternoon, as well as a reminder earlier this week. It has the link directly to the page on which you can download the public deliverables.
Thank you.
Thank you. I'm going to thank you very much, Mark. I'm a little concerned if we have one more question, that'd be okay. But we do have some other things that we need to cover. So is there someone else who would like to ask Mark a question before we go on our agenda?
Yeah, this is Dave Erickson from Logistiview. Mark, I wanted to touch on, I looked at the slide where you had the different examples of people using this, right? And one person is using, is basically working on a wheel in front of them, and another person's doing a medical procedure, etc. And I'm wondering, some of there's different levels of value in, a repetitive task, recording the ghost user on the repetitive task that, everybody should know how to do, flipping a switch, there's no value in it. But things that are non-repetitive or rarely done, that's probably where that comes in the most handy, right? To see how the expert did it. I'm wondering if you were able to put any kind of feel around that or framework around that, is kind of what's the threshold of what makes it worth it to record the expert and make that available, or what were the criteria for when that actually pays off?
Sure. Well, the tasks were designed to be, completable within 5 to 10 minutes, and so they were designed by the experts in order to kind of minimize really repetitive work or things that could prove too difficult. But the intention was to still keep things fairly technical. For instance, with the wheel change on the air ambulance aircraft that you saw, that was chosen specifically because it's something that the engineers have to do on an almost daily basis. But it's not an extremely long and complicated task, but it's one that does have its technicalities, and it obviously has to be done really, really well.
Great. All right, everybody. Thank you. Thank you very much. Oops. Okay.